So we'll continue chain rule.
Why am I here?
And I think we're going to get far enough today to get to examples. I did also, however, remember that there were two other derivatives that I forgot to put up here, but they're usually super obvious. Whenever they come. When did I order them? Half a week ago. Sometimes they come in 2 days, sometimes they come in a week. I have no idea what the process is.
Today?
Whenever it takes me.
You said today, right?
Not everybody did it yesterday. I was kind of hoping everybody would. They did not. Okay, the two that I forgot, I feel like are semi-obvious because you know if it's a natural log derivative and you also know if it's an e to a power derivative. But I did forget about those, so those are part of this as well. I would say a majority of the problems are going to be power rule or trig. I believe yesterday we only did power rule.
Yes.
Okay, so I wanted to venture into trig today. Now, I know I've said it multiple times, and most people just flat out don't believe it, and I sort of get why. Trig is by far the easiest derivatives. It may not be the easiest for you to evaluate trig functions. Like on the test, I know there was a trig one, I forgot what it was, like something of pi thirds or something. Still tons of people getting that wrong. So, evaluating trig functions is not the same thing as doing a trig derivative. So, trig derivative, the derivative of tangent of u, which I've got, I realized I forgot to write the answers up here yesterday. I wrote these and then I never got the chance to write the answers. So, this morning I put the answers up. So the derivative of tangent of u is secant squared u times the derivative of the angle, so u prime. The derivative is no different. Derivative of tangent itself is just secant squared. The only difference is whatever is in the angle position, you're going to multiply by the derivative of whatever's in the angle position. So previously, the problems we had before would have been tangent of x. And the derivative of tangent of x is secant squared x. And that's where we stopped it. But it still does actually fit the chain rule version of the derivative. The derivative of tangent of u would be secant squared, same u, but then at the end you would multiply by the derivative of u. So the derivative of x would be 1. So we purposely did everything with just regular x's before, so that you didn't have to get confused by this extra little part. Okay? Oh, you don't have to roll it. Oh, it's up there.
Yeah.
Is there somebody else that would like to roll?
Oh.
I apologize. We got the new roll.
And I can't use the new one.
Well, you worked the old one, fantastic.
So you're
Minutes.
exactly, that's why I need.
I mean, you really only had two choices, either forward or backward. What?
11.
11. Somewhere over here, I think. No one's at 11, so let's pick a desk that doesn't have a number, which I feel like is one of these two.
You both got picked. You want to?
So Jason, oh no, you got a number on yours.
Oh, yeah, did it?
Vincent,
Okay.
I don't know what your number is, it's kind of ripped up. Vincent, help me out.
Alright,
I can give you some guidance if you want, but just, I thought I'll let you pick their end.
So wait, to separate it, I guess, like the inside's just the.
Oh, so like inside, outside?
Yeah.
Sure. I thought I clicked on red and it was blue. I don't know what it's doing.
And then tangent into secant squared.
You're not wrong, but it doesn't turn into it. I mean, like, I get what you're saying.
Oh.
The reason that I don't wanna say turn into it is because some people feel like this means multiply almost, but it's not multiply. Okay, so secant squared, did that.
And then, just like, put the same, like, put the inside next to it.
So keep the exact same
Yeah.
inside. Perfect. What? That was my brain short circuiting.
And then at the end, multiply it by, 6x plus 2.
Like that?
Yeah.
No.
Parentheses.
Now, what you told me was perfectly correct, actually. So like your derivative was great. I'm going to write what a lot of students write, and I need you to tell me why it's wrong. This is what a lot of students write, and it is not correct. It is not the same thing as what you were trying to say out loud. Oh, is there anybody that knows why that's wrong?
Is it, wait, are you supposed to put the parentheses around like?
100%. If I don't put parentheses around this, technically the 6x is the only thing being multiplied. The plus 2 would be, oh, no. The plus 2 would be considered like very separate from everything else. And so I just want you guys to know that if you write that without a parentheses, it means something different and I will mark it wrong. I know you intend it correctly, but I definitely cannot grade something on what I think your intention is.
would that 3x squared plus 2x be to the negative one? Or no?
We didn't do the power rule.
Oh, are you sure?
I think that's what you're
Yeah.
thinking of, yes. But actually, that would be to the 0 power.
Alright, okay, that's, I mean.
Okay, now next thing, you generally will never see the answer written like this. I'm assuming it's because they don't want people to get confused as to what the angle is, like maybe you would accidentally think this whole thing is the angle. And so the way they traditionally will write this answer is the u prime will be in the front. But the great thing about trig is there's generally very little simplifying. Like, we're not gonna do any simplifying, we're just writing this in the front. Okay, nice job, that was a good start for today already. I don't know if I'm worried about, like, I feel like you guys are doing better on chain rules than I was expecting, which is not a bad thing, but I'm hoping I'm not overlooking something. Like, does it feel like it's going okay for you so far? Okay, why don't I put up an example for you just to try, like a trig one? I won't give you the horrible, horrible ones yet. Why not? I wanna work our way up to the horrible, horrible. I'm trying to think of something different here, like not just a polynomial.
Can you like put like a sign inside of it?
That's the horrible, horrible one.
Oh.
So yes, you can. I'll just put, oh, I think I know what you meant. Sure. Try to find that derivative. Sorry, what?
Do you have to put like a f of x or like a y equals at the front of it, or?
Oh, I forgot that. That pretty much will always be there, but now that you said it, you don't have to, but, right, I'll put that there because it's easier for knowing what your answer is. Oh, yeah, I got them on the board if you forgot them. It's a good question.
It is.
What you're intending is the exact opposite.
Yeah, I just wanted to know if like.
It does not reverse, no.
Oh.
The derivative of ln is one over x, but it's not the other way around.
Okay. Derivative of 1 over x. Okay. I don't know.
General means you basically do nothing different until at the very end of the problem. Who do we got for the roller? I think that's enough time, they'll either know how to do it or not by now.
38.
Oh, I need to take 38 out. And we only have till 36. The person who put them in this morning went all the way to like 45 or something. Huh? There is no desk number 36.
35.
I have to renumber the desks, right? 35? Sure.
It's 29.
You actually have a number on yours? 29?
Yeah, I'm 28. I'm 9.
Really? What on earth? Alright, sounds good.
Oh, I have no clue.
What?
No.
You have no clue?
0.
Oh dear. Let's pass it on to somebody else. Yes.
Okay, so the derivative would be negative cosecant x times cotangent x. And then you drop the 1 over x, like down.
Oh,
Like
like,
this, yeah.
like that?
Like you put it like the 1 over x at this side. And then times plus negative 1.
Wait, what?
Okay, the reason why I did negative 1 is because like,
You wrote this as x to the negative 1.
yes,
Okay. Is that what you were trying to tell me to write?
yeah,
Why did you say x to the negative 1? So x to the negative 1 right here.
yeah. And then,
More?
yeah, I put, no, I put,
It is.
oh. Then I put negative 1.
Okay. Where do we agree or disagree?
Why is it x instead of 1 over x?
I just wrote what you told me.
Oh,
I said, well, where do we agree or disagree or what? Like,
that's,
I didn't say this was right. I wrote what you told me.
You said it was wrong.
I did say it. I wasn't trying to say that one very well. Oh, you're not asking.
I can.
Jason?
is it like the derivative of like 1 over x, like negative 1 over x squared? Like the x is x squared.
Mm-hmm. Mm-hmm.
Okay, so. What?
Well, you didn't tell me what to do with it. Like, you just-
Yeah, so like that would replace like negative 1.
So you think that should be right here?
Like after like the x to like the power of like negative 1, because like that's just like 1 over x.
So instead of where the negative one is?
Yeah, just like replace that.
That's even worse. You guys are making this too complicated in your brain.
Is the first one.
Okay, Pop, I'll erase the things that are not correct, but are on the right track. Like, this whole answer is absolutely close, but it's not right. Like, the problem with calc is, you know, it's either right or wrong, right? Like, there's a lot of parts to it.
Oh.
The stuff And the sides should stay the same.
Okay.
Still be one of
The parentheses will actually never change. No matter how horrible this parentheses is, that will always be the exact same.
And then the derivative, wouldn't it be negative one x to the negative two?
Yes, and that's kind of, that's what Jason had said, he just said it in the simplified answer. So yes, so now you would do the derivative, when you wrote this, you were like halfway there. So this is what you're gonna take the derivative of. You need to take the derivative of x to the negative one. And then that would be negative one x, subtract one. And then this last portion could absolutely be written differently. So you could write that as negative one over x squared. Two different negatives turn to positive. So we would have cosecant 1 over x, cotangent 1 over x, all over x squared.
Do you have to write it like that, or can you write it like the first reading?
Not wrong, but not fully right.
Will it be wrong on the test?
Fully right, yes. It would be slightly wrong on the test. I'd take off like half a point because you didn't simplify your answer.
How did you get the derivative of 1 over x?
Okay, so 1 over x, we want to write it as power rule, or like as a power, so we can use the power rule. So 1 over x, you write as x to the negative 1 power. And then anything with a power, we can do the power rule. So negative 1 goes to the front of the x. And then the new power, we subtract 1 from it. And so then that's the negative 2. So here's my opinion on why a lot of people find power rule, on why a lot of people find chain rule difficult. It's because they try to do a lot of the different steps in their head at the same time. Not that that's bad. When you practice something enough, you can do it. You solved the Rubik's Cube. You didn't? Impressive. Because that thing is also pretty rickety. Like, it's very difficult to even turn the pieces. My son beat on that thing a lot when he was young, so he just basically threw it all over the place. So those pieces don't really work very good.
Or like, just like.
So I understand like when you have like the one that you have to learn like the negative 1 equals the negative 2. I understand that when you run it down the negative 2 became positive, but why did the negative 1 like turn into a positive 2?
You guys have terrible minds, and I did not even say that. I think that's what you're asking me?
That's crazy.
Yeah. I was thinking about the last one, but I didn't even notice it.
Yeah. The derivative of cosecant has a negative in front of it, and then the negative from that derivative together. There's just two negatives, so it's positive. Okay, here's the one that looks simple and is in fact actually kind of difficult. Should I give you a chance to just try this on your own before I say anything? As long as you leave some space to either cross out your answer or erase it. No, you can just try it and cross out if you're wrong. It's not terrible. You can't be a mathematician without making lots of mistakes. So you just learn to cross stuff out.
Oh, is it like multiply then cosine rule or product rule? So it's sine times
Anybody figure out why this is harder than it feels like it should be?
Is it because you have to use product for it?
Oh, you can use product rule, sure, that would actually work. Not what I was intending, but product rule would work. Now, do you guys want me to explain where product rule even came from, like some of you? Okay. There's two different ways to view this problem. One way to view this problem is sine squared is the shortcut notation for sine of x squared. The other way you can view the squared, which what Sophia did, was sine of x times sine of x. They'll both give you the same answer. Try to do one of the two. I mean, I don't know, it's guaranteed this is gonna be on the AP test. Every year they have either sine squared x or cosine squared x. And they feel like they should just be a super easy answer. Like, a ton of people will accidentally write cosine squared x as the derivative. But it's viewed like one of these two. All right, Sophia, who we got to help me with this one?
26? Oh, that's me. Okay, so I started on the left side.
Okay, that's what I prefer as well, just because it feels like less steps.
Yep. Okay, so I brought the 2, yep, and then the 2 in front, so you get 2 times sine x. Because then you subtract the 1 from the 2, and then you multiply it by cosine x.
So most people will just write the answer as 2 sine of x cosine of x. Now the product rule one, I'm assuming you guys want me to write that one up there relatively quick. Okay? The product rule one isn't actually that difficult either, just because the two parts are, well, they're the same. So product rule, you would do first derivative of second plus second derivative of first. And so if you have sine of x plus, if you have sine cosine plus sine cosine, that's 2 sine cosine. So it's like 1 sine cosine plus 1 sine cosine. And it doesn't matter which one you write first. I was about to write cosine first, it's still the same thing. Okay, with our 25 minutes left, would you either like me to start, would you like me to put up a difficult problem? Or would you like to kind of start homework together first? Oh, I printed out homework for you. A, I didn't print out the homework from the packet. B, it's my paper, I get to do what I want with it. She's being sassy. I am sassy frequently. But it's my classroom, I can be. No, what I did was I found a circuit worksheet on the chain rule. So, what? No, I didn't pay for that. Yeah, you paid for that.
Did you take the time to put the A in it needs bubble letter?
I did not make this worksheet. I will pretend that I did. That's okay. A kind old lady did, and it appears that way. A kind old lady made this worksheet, and it looks like the old lady made the worksheet. Yep. It's got fonts that I would never choose.
You would never do
It's got dotted lines all over the place.
Yeah.
There's nothing wrong with it, but it just like, it has the feel of old lady.
Yo, Adam. got you.
No, I got negative sign. Oh, why does it change to negative sign? Put the
Now, this worksheet,
That's crazy.
what are we doing?
My pencil in the trash.
What's the deal in the trash
I
can?
don't know, you just threw my pencil in there.
You keep losing stuff in there.
You grab it for me?
No.
Derivative of.
Okay, I don't know if you've done circuit worksheets before.
Oh, shit.
They call them, oh, I bet you, Miss Larson had a bunch of them last year.
Who was got it? Who was got it?
Okay, but I know not everybody has Miss Larson, so I will go over how to do this. First thing, it's just paper in the garbage can.
No,
What do
I
you-
saw a tissue in there.
Oh, all right, that's fair then. The first question here is not that difficult, it's just like, I'll call it a one-stage chain rule. There are gonna be questions that have chain rule for 2 stages, and that would mean that you have to do the chain rule twice within the same problem. I figured you would get a certain distance today, and then tomorrow we would still work on problems together. I thought it might benefit you to just try, I don't know, we'll call them level A questions that are just straightforward chain rule, just to get used to chain rule. There is some level B questions which are like involve product rule or quotient rule. And then the level 3 would be like embedded chain rule. We'll get to those tomorrow. Okay, so we're gonna do the very first box, and we're gonna come up with the answer. I would bet some of you are at the stage where you can do some of these chain rule in your head now, rather than write the parts down. So derivative of cosine, negative sine, write the exact same parentheses, and then multiply by the derivative of the parentheses, so in this case, 8x. Now these answers are all gonna be simplified like multiple choice. So the answer that you'll find is gonna have negative 8x in the front. Not that it's wrong afterwards, but that's just, excuse me, how you'll see the answers. And then if I remember right, this answer is somewhere over here pretty close. Scroll, there we go. Okay, perfect. So then F is going to be the second problem we do. And then once you start this problem, this answer is going to be somewhere else. And then as you go through the different boxes, the very last box, its answer, hey, we're supposed to be an A. I was going to say the very last box, its answer is supposed to be right here. Sweet, okay. Glad I purchased this, sweet old lady. Oh, I definitely don't care about that. I definitely don't care about the, I did not even notice that. There's a word puzzle at the bottom with the answers. Okay, well, a circuit worksheet is supposed to have the very last problem. You verify that you did it correct because the answer should be right here. And they're considered self-correcting because every correct answer should be used accordingly. And if your boxes don't work out right, then somewhere along the way you made a mistake. Now, my guess is these answers are all gonna be different enough that you're not gonna accidentally pick the wrong box. That's the one good thing about calc getting more difficult, is that the answers kind of are so crazy that they're, you already got it wrong, all right, good start. Do you need me to help you with question number 2?
Yes.
Okay. Everyone got it wrong, oh my goodness. so glad we spent $5,000 on a smart board. Okay, first thing, rewrite the original problem as the negative third power. Okay, if we're gonna do one of these derivatives from up on the whiteboard, it has to be one of these categories, right? So it has to either be a power, a trig function, or natural log, or e to the something. This can only be written as a power, so I would bring it to the numerator and write it as negative third power. Now I'm gonna do power rule on the negative third power. So negative 3 in the front, keep the parentheses identical. You're the one that got it wrong, why wouldn't you watch me helping you do it? Subtract 1 from the power, and then at the end we have to multiply by the derivative of the inside or the derivative of the parentheses. And so derivative of negative x to the fourth, negative 4x cubed. The answers have to be simplified like multiple choice answers. So this one would be simplified, negative 3 times, this parentheses doesn't have a power on it, so we can combine those two things. This would turn into 12x cubed on the numerator. On the denominator would be this negative fourth power as a positive fourth power. Now, I didn't even look for that answer, but I'm assuming that's one of the other boxes. M, excellent. Okay, I wanted to give you guys here this last 15 minutes to try to work on these. And even if you struggle, just try them, just try them. And technically, you don't have to do the circuit portion of this. You can just go through and do every single box, and then do the answers later. Like, you don't have to like follow the order exactly. Yeah, somebody reads it, that was nice of them. Yep. Unless I forgot to write prime, which is very possible. Oh. Okay, I'll stop it here. We'll get 15 minutes, I can help you with questions. Tomorrow I want to kind of throw up the more difficult.